Okay guys, so again, this is 504 Momentum and Impulse CFU, and I'm looking at question number 4. I'm just going to go over a few of the questions just to make sure that we have these down, and I'm kind of looking at the ones that were most missed. And again, if y'all have questions after I go over these handful, you can ask. Number 4 says, Bodhi and Carla are both riding their bikes when they collide and both fall to the ground. Assume both fall from the same height, both were traveling the same initial speed, both have equal masses, and that both hit their heads on the pavement. The only difference in the circumstance of their collisions is that Carla was wearing a bike helmet, whereas Bodhi was not. Which statement or statements is correct regarding this scenario? Select any or all that apply. So this is very similar to the scenario in the notes. We've looked at a couple different ones. But the scenario with like the truck that hits the hay versus the truck that hits the wall. Okay, if you don't, it's the first example that I gave. We also looked at like an egg hitting a bed sheet versus an egg hitting a wall. But in both of those scenarios, it's the same thing here. Okay, in both of those scenarios, we're dealing with a situation in which there are equal changes in momentum. Okay, because they both have the same mass. And when they're falling from the same height, they're both going to have the same change in velocity upon hitting the ground, right? They're both going to be moving the same speed when their head hits the ground, and they both have the same mass. And because they have the same mass and the same change in velocity, they're going to have the same change in momentum, because change in momentum is mass times change in velocity. And if this is the same, that also means that the impulses are equal, because impulse is change in momentum. Okay, so that means they have equal impulses as well. So let's take a look at the answer choices here. This one is talking about time, so let's go ahead and look at that too. Who has more time, or is that the same also? Okay, and that's the thing that's not the same. Okay, although the impulses are equal, the forces and the time are not. This is just like with your bumper the other day too. Okay, when you guys ran that thing down the track, you wanted to have a greater amount of time so that the force was smaller. Okay, if the time is shorter, if you have a smaller time, you'll have a larger force. This is that relationship we've talked about over and over and over again. And the person who is going to have a greater time to come to a stop is the person wearing a helmet where there's padding and there's give to it, just like your bumper had give to it, just like an airbag has give to it, or the hay versus the wall. Okay, and the one that was wearing the helmet is Carla, and therefore Carla would have increased the time, not Bodhi, Carla. This one is Carla. This one is Bodhi. Okay, so Carla has an increased time and thus smaller forces. That's why we wear helmets, okay, whenever we're riding our bike or playing football or whatever it may be. Okay, so Carla does have increased time, and then my options don't have a choice for equal impulses. Your options might. You need to read them because they say something different than mine do. Okay, if I had a choice here to say that they had equal impulses, I would pick it. I just don't have it on mine. Okay, so again, you need to be able to work through kind of this thought process here that I have up there, but we've seen it again and again and again in class. Okay, that's the same idea here. Two vehicles, a semi-truck and a small car, are traveling toward each other and then collide, bouncing off of each other. Which of the following statements correctly describes the collision? Again, same idea as in the notes, the bug in my car, same thing. The bug hits the windshield hits the bug. We've talked about that example before. But again, it's a force pair. The force on the semi-truck will equal the force on the car. So do we have a choice that says forces? No, these are all about impulse. There is force, but it's not greater, so I can't pick that because that's not true. But again, yours might say something different. If you have an option to select that they have equal forces, you should pick it because they do. The forces here are equal. Okay, so on this one, you're dealing with a situation in which the force on the car is equal to the force on the truck. Okay, however, oh, and by the way, the times equal too. It's impossible for the truck to be hitting the car without the car also hitting the truck, so the times are the same. And so if the forces and the times are both the same, then of course that means that the impulse is equal in that collision. Okay, but the masses aren't the same. Remember, impulse is also change in momentum, therefore the change in momenta is equal, but you have a very small mass for the car, so it's going to have a large change in velocity, whereas the truck, which has a very large mass, would have a much smaller change in velocity. And again, we've looked at this relationship as well. Okay, so that's what I'm dealing with here. They do have equal forces. I don't want to say the car is greater. The car does, however, have a greater change in velocity. That is absolutely true. It has less mass. It will have a greater acceleration as a result of that. That's this right here. Here's my car. Here's my truck. Okay, my car has less mass. It will have a greater change in velocity. They do have the same change in momentum. I'm going to select that box. Okay, all right, that's the only two I can select. Again, read your options, though, because they're going to say something different than mine. But these conceptual questions on last year's test were some of the ones that were most missed. This is one of the calculations you guys are struggling with the most, and I already know why it is, and maybe you have already figured it out too. But let's go ahead and take a look at this problem. It says, okay, a 2.96 times 10 to the third car traveling to the north is slowed down uniformly from an initial velocity of 30 meters per second by a 4,390 Newton braking force acting opposite the car's motion. What is the car's final velocity after 6 seconds? So this car is moving along, okay, and it's moving to the north, so its velocity might be this way. Let's call that north. Okay, but I just realized y'all can't see that. But the force on it is opposite the direction of motion. So if I was to draw my force on my free body diagram, that's the only vector I'm going to draw because it's moving this way, but it's slowing down. Okay, so when my force is opposite my velocity, or my acceleration is opposite my velocity, of course I'm going to be slowing down. But this is my 4,390 Newton braking force. Okay, right there. So let's go ahead and label the information we have. We have a mass, 2.96 times 10 to the third. You're welcome to leave that in scientific notation, but it's equal to 2,960. So I'm just going to write it in terms in standard form, but that's my mass. I know that my initial velocity is, I'm going to go ahead and call north the positive direction. So I'm going to call this positive 30 meters per second. My force, however, is opposite that direction. So my force, when I label it, is negative. Okay, that might be where you made a mistake. But again, if the force is causing you to slow down, it needs to have an opposite sign of your velocity. So negative 4,390 newtons. And I know I'm looking for how fast the car is moving after 6 seconds. Guys, if you look at your list of variables and you have mass, force, time, and something about velocity, you're going to want to use this equation. F times T equals M times delta V. Look, that's all the variables I've got there. Okay, remember delta V is VF minus VI. So you could solve for delta V and then find your final velocity, or whenever you write this equation, you could actually substitute in to VF minus VI, which is what I'm going to go ahead and do. It doesn't really matter which way you choose to do it. But I'm going to do negative 4,390 times 6 equals my mass, 2,960, times VF, which is what I'm trying to find, minus 30. Okay, I'm just going to plug it in with VF minus VI instead of delta V. You could solve for delta V first and then find final velocity, and that is also fine. You can do that instead. Okay, so we need a calculator. Let's go ahead and multiply negative 4,390 times 6, and that is equal to negative 26,340. And then over here, I need to distribute this into my parentheses there. So I have 2,960, 6 times VF minus, and we need to figure out what 2,960 times 30 is. And that is 88,800. Okay, so that is my next step algebraically. Okay, from here, again, I need to isolate this variable, so I need to move this over here. These are not like terms. Please do not attempt to subtract them. Okay, we're going to add 88,800 to both sides. And that's going to give me this 62,460 equals 2960 VF. And now I can divide both sides by 2,960 to isolate my variable. 2960, I'm dividing by that, and I get a final velocity equal to 21.10 meters per second. Okay, now if I had solved for the change, okay, I would have gotten a negative change, and then I could have worked with this and the change. So my velocity was 30. If my change was negative 10, then my new velocity would be 20. Okay, but I just went ahead and plugged it in here to solve for it directly. So I got 21.10. Submit. Okay, that was number 7. Number 8 is another one that some people are having trouble with. Oh, before I go on though, does anybody have a question about number 7? Again, the thing you need to make sure of is that you get your signs correct. Okay, if you missed it, that's probably why. Okay, is that you probably forgot to put a negative sign in front of that force, or maybe you didn't know what to do with your change in velocity when you found it and got a negative number there. I don't know. Or maybe you tried to put that here. Okay, you need to make sure you solve for the actual question, final velocity, not the change. All right, number 8 is another one that people are having trouble with. And it's for a similar reason to the last one. It has to do with signs. Okay, again, I've got some people that are not getting the sign correct here. It says a softball with a mass of 0.27 kilograms. So let's go ahead and start by labeling that. 0.27 kilograms. Moves at a speed, an initial velocity of 17 meters per second. Then it hits a bat and rebounds in the opposite direction at a speed, so a new velocity, VF, of 20 meters per second. However, again, it says opposite direction. So I'm going to say that this was positive 17, and therefore this has to be a negative number. Your signs have to be opposite. Now, it didn't actually define this as positive, so if you called this negative and this positive, that would be okay too. But if you have something bouncing and going backwards in the other direction, you need to have opposite signs. If you're missing this question, that is why. And it's probably, you're going to see something similar tomorrow, I think, okay, on your test. So make sure you're careful about this. So my final velocity is going to be negative 20 meters per second, and I'm looking for impulse. Now, impulse is force times time. And I don't have either of those things. But impulse is also equal to change in momentum. And change in momentum is equal to mass times change in velocity, which means impulse is equal to mass times change in velocity. So again, there are 2 different equations you can use here to find impulse, and also 2 different equations you can use to find change in momentum. Both of them are equal to Ft, and both of them are also equal to m times delta v. And those are equal to each other. That's why we have that other equation. Okay, so I can solve for impulse with this formula because I have a mass and I have 2 velocities. And so let's go ahead and do that. J equals my mass, 0.27, times my change in velocity. Again, I can find the change first and plug it in, or I can just plug in VF, negative 20, minus VI, 17. Again, make sure your signs are correct. Negative 20 minus 17. Okay, which really means I'm adding these numbers together. I'm going to get a bigger negative number. Okay, that's going to be negative 37 times 0.27. And so that's what I'm going to type in my calculator, 0.27 times negative 37. And I'm going to get negative 9.99. And impulse we typically measure in Newton seconds. Sorry, I wrote that kind of messy. Newton seconds. Okay, so let's go ahead and do that here, negative 9.99. And my units, I got a lot of choices here. I'm going to pick Newton seconds. There it is. Submit. Okay, I believe that this will accept an answer of positive 9.99 or negative 9.99 because of the wording, because it says speed here and it doesn't define the direction. So if you had defined them opposite me, you would have gotten positive 9.99, but we would have gotten the same magnitude. And I believe this one accepts it either way. All right, last one I want to look at, and then if y'all have questions and we have time, we can go over them, is this one, number 10. And I want to look at this one because this is what your free response question looks like. Okay, so you really want to make sure that you know how to do this one. It says, two brothers ride a sled in the snow. The combined mass of the boys and the sled is 181 kilograms. The sled slides rightward for 14.5 seconds. I'm labeling things as I go. Across the surface of a frozen lake until it comes to a stop. The coefficient of friction between the sled and the ice, mu, is 0.065. A physics student drew the free body diagram above to describe the forces acting on the sled for the scenario, which describes that free body diagram. Okay, based on the scenario described, there is no applied force. This sled is already moving, but it's slowing down because of the friction between the sled and the snow. So I should not have an applied force here. Otherwise, this looks okay. The rest of it's fine. Okay, I do need to have friction. I do need Fn and Fg. These should be equal and opposite to each other. And so the answer I'm going to choose is the only horizontal force needed is Ff, thus Fa should be removed. Okay, you're going to have to draw a free body diagram. I'm not going to give you one like this, but you need to know how to draw something based on that scenario. All right. Underneath that, we've got three questions. What is the change in the sled's momentum as it comes to a stop? What is its initial velocity, and how far does it slide? Change in momentum is equal to either force times time or mass times change in velocity. Okay, and if I look here, I have a mass and a final velocity, but I don't know the initial. Okay, and so I can't solve it that way. I do have a time, but I don't have a force. However, remember my free body diagram, actually I'm going to redraw it. This is my free body diagram. Fn, Fg, Ff. So my net force is Ff, because that's the only force that's there that's not canceled out. If I can find force of friction, I can find my force, and then I can do force times time. That's how I'm going to get to that answer. Okay, and I can find force of friction because I know force of friction is equal to mu times Fn. And I have mu, but I need to find Fn. I don't have a formula for Fn, but I do have one for Fg, and I know Fn and Fg are equal and opposite to each other. This is the same process we've been doing for the last 3 units. Okay, find Fg. It's a good place to start. It's useful in most of the time whenever you have forces. Okay, so let's go ahead and find Fg. It's my mass, which is 181 times 9.8. That's going to give me 1,773.8 newtons, and that's not just Fg, that is also Fn, which means force of friction equals 0.065 times 1,773.8. So I'm going to take that number, I'm going to multiply it times 0.065, and that is my force of friction, 115.297. That is also my net force. And I do want to go ahead and tack a negative sign on in front of it because it's going in the negative direction. It's causing things to slow down. Okay, so now that I have a force, I can multiply it by my time because I know impulse is equal to change in momentum, and both of them are equal to force times time. Okay, so we're going to take this force, we're going to multiply it by the time, 14.5. Okay, and my change in momentum will be negative 1,671.8065. Okay, so what is the change in momentum? Negative, and I do need to make sure to type the negative. I didn't type it in my math, but I wrote it here. Negative 1671.81. Okay, is the first answer. So that's my first question. The second question says, what is the sled's initial velocity? Well, now that I know my change in momentum, and I know that change in momentum is also equal to mass times change in velocity, I can solve for my velocities. Okay, I have one of them, I can solve for the other. Okay, so I'm going to take my answer, negative 1671.81. I'm going to use the whole value, but I'm not going to write it all out. Equals 181 times change in velocity, which is VF, 0, minus VI. Okay, and so from here, I'm going to get rid of that 0. I have negative 181 VI. I have negative 1671.81. I'm going to divide that by 181. Those negatives cancel, and I get 9.2365. Okay, now you're going to do the last one, which is going to require kinematics. Okay, I have now, and I know that's our bell, I have VF, I have VI, I have time. I'm going to use this equation. Delta X equals VF plus VI divided by 2 times T. That's how you find it. Okay, that formula right there is how you find it. Guys, you have a test tomorrow. Please make sure that you study tonight. If you have further questions, come in for tutorials. I'm going to go ahead and finish this problem. Y'all can walk out, but I'm recording it. Yeah.
So, for this, because you have a padded dashboard, are we assuming that you just hit it and it's pushing, like you're not bouncing off it?
All right, so VF 0 plus VI, which is what we're trying to find. Oh, no, sorry, we found that a second ago. 9.2365 divided by 2 times 14.5. So we're going to take our previous answer, divide it by 2, and multiply it by 14.5, and we get a displacement, delta x, of 66.96. And the site timed out. All right. There it goes. So those were the most missed questions. Hopefully that helps as you're reviewing.